made lasagna last time and it was so good.
I don't really like lasagna. Actually, I don't like lasagna.
You would like my lasagna.
I don't like lasagna when there's like
Okay, all of your formulas are on the board, so we'll be referring to those. If you want to write them down again, go ahead. But I'm just going to do a few examples. Okay, we've got a point on a circle travels 5 centimeters in 2 seconds. So a point on a circle.
Where'd Becca go?
Oh, she's taking the quiz. Becca's taking the quiz across the hall. Yep, you guys remind me. Schwartz. It's ground mace.
Oh, that's good.
Isn't that dangerous?
I don't know. Travels 5 centimeters in 2 seconds.
Ground mace. What is?
I don't know. I've never used mace. I don't own it. We'll start easy.
I was gonna say, doesn't that seem like something you cook with?
I don't know what you put mace in.
People die.
Pepper spray.
Well, that's like a McCormick thing. That's like a spice that you cook with.
It is a spice that you cook with, but
Ground mace?
I've never used it.
Like if someone $5 to put it
Google it.
there.
See what I
Okay, let's see what's given. Well, first, what are we trying to find? Label everything with your symbols so that you can at least get a formula to go with.
Or trying
Linear
to find velocity.
We're trying to find velocity. This is a point on a circle travels 5 centimeters in 2 seconds. Well, obviously, this is time. What's that 5 centimeters giving us? That's giving us S. Centimeters is a distance. It's traveling on a circle. So you see you have a circle. Here's your point that's traveling 5 centimeters. Got to have a picture. Here's your mace. Are you cooking something? We want to know what you use this for. We're intrigued. We want to know. Oh, you want the receipt too? What do you cook with that?
It's for finance.
It's for finance.
Oh.
You're not cooking anything.
Is it expired? Yeah. Oh, gosh darn. Now I really want you to taste it.
Okay.
Do you have to like go buy something that's expired? That?
What is it? What is this 5 centimeters? It's not a radius. It's S. That's an S. Once you realize that's an S, this problem is very easy, because how do you get linear velocity if you know S and T?
S equals T times V?
Up on the board, V equals
S over T.
S over T.
It's just 5 over 2?
5 over 2.
Whoa.
5 over 2 what?
Where is the
Centimeters per second.
Austin, what's your question? That's my generic point on a circle that's traveling. Easy. That should have been easy.
Okay, which one? Okay, so V is linear velocity.
Correct?
W
Is angular velocity. So all of the V's will be some kind of a distance over time. Okay, number 2.
How many examples are there?
I think 4 or 5. A point on a circle rotates through 3 pi over 4 radians in 3 seconds. Can you find the angular velocity? So if you need to draw a picture, you draw a picture, if it helps, if you get lost. Here's my point P. It says it passes through 3 pi over 4 radians. What is 3 pi over 4 radians giving me?
Theta.
That is theta. It's not almost theta, it is theta. In 3 seconds. There's my time. So it's traveling through an angle. I don't know that far. wants me to find the angular velocity. What's angular velocity? Yay. Once you identify everything that's given, and especially what you're trying to find, can you eliminate or narrow down and find a formula?
Yeah.
Which one are you going to use?
Theta over time.
The butt cheeks one is theta over t. We know theta is 3 pi over 4. We're going to divide that by 3. If I want to be exact, I want to see pi in the answer, what's going to be our algebra to do that? Yep, we're going to make that over 1. We're going to use junior high fraction rules. We're going to keep the top the same. We're going to flip the bottom over and multiply. And we will get pi over 4 what? Radians per second. Ready to get to the challenging ones? Yep.
I'd rather just do these for these. Come on.
I have 3 more. Let's see, can I fit this? I'll squeeze this one on here. Okay, we've got a record. Anybody have those record players anymore in their house? The old needle, spin around. Yeah. A record is turning at 45 revolutions per minute. If the distance from the center of the record to a point on the edge is 3 inches, distance from center to edge is 3 inches. Can you find the velocity in feet per minute? Okay, this is a challenging one.
I feel like the first thing I would do is change the inches per minute.
I do that off to the side. I like to identify everything that's given first. So anytime I get this double whammy here, I like to break it up into the 2 parts. So 45 revolutions is giving me almost theta per minute is my time. The distance from the center to the edge is 3 inches. Radius. What are we trying to find?
V.
Big V. We're trying to find big V. Now we'll check out, are there any red flags?
We need the answer.
Any red flags? Units?
Yes.
We've got minute and minute, that's good. Where's my red flag at?
Inches and feet.
Inches and feet. Okay, so let's find theta. How do I get it?
Times it by 2.
Times it by 2 pi. So I'm at 90 pi radians. My time is
1 minute.
per minute, that's 1 minute. And that was not a red flag, so we're good there. My radius is 3 inches, but that is my red flag. I got to turn that into feet.
1, 4.
Let's do the little, I forget what they call that in chemistry, where you do your little T-box thing. Stoichiometry. What's your conversion for inches to feet? 1 foot equals 12 inches. Where does the 12 belong in this stoichiometry box?
On the bottom.
On the bottom.
I just did this last time.
Okay, what is that? That little thing under this thing?
Nothing. That means don't put anything there. Blank. So do you guys know how this little box works? It's like fractions multiplied, and then you can reduce here. So what do we get for radius?
3 12s.
3/12 or 1/4 of a foot, or 0.25 feet if you like, because it's exact. Whichever one you want to use. Do we have everything we need to find big V?
Yeah.
I got R, I've got theta, I've got time. Now it's just a simple plug and chug. So big V, kind of running out of room here on my sheet, equals R times theta over T. R was the 0.25. Theta we found to be 90 pi. And time was 1 minute. So 0.25 times 90, I don't know if it doesn't matter whether you give exact or approximate, if the problem doesn't say. It'd be 22.5 pi as an exact. If you multiplied by the pi, that'd be 70.68, or 70.7, we'll just go there, feet per minute. Any questions on that one?
Wait, what do you do after you...
I multiplied the pi, 22.5 times pi.
Oh.
What?
Just keep it in high or no?
It doesn't matter. It doesn't matter. If the problem says be exact, that's your exact. If it says approximate, there's your approximate. If it doesn't say, go with whatever you like.
Okay.
Your choice. Two. Going on the Ferris wheel now. What am I on? 4?
Yep.
Okay. Ferris wheel. The diameter of the Ferris wheel is 250 feet. The distance from the ground to the bottom of the, oh, I don't need that. One complete revolution, takes 20 seconds.
Holy crap.
That Ferris wheel is flying.
Yeah.
Can you find, 20 seconds is a long time.
Not for a Ferris wheel.
Oh, you don't think?
Cars will be flying off.
Find the linear velocity in, let's see, we're going to find it in miles per hour. We got a good concept of miles per hour. Miles per hour.
I just put MPH.
MPH is fine. Okay. Identify what's given as labels, little variables.
We have time.
We have time.
We have diameter, but we can cut it in half and make the radius.
So we've got almost radius here. And 1 revolution. Almost theta. Do we have any red flags?
Yeah, we need, yeah.
How many red flags?
2.
2 red flags. We've got miles and feet. There's a red flag. We've got seconds and hours. There's my second red flag. So both of them are going to have to get adjusted.
Awesome.
And we're trying to find big V. I know, isn't that awesome? So, let's start with the radius. What is the radius?
It's 125.
125 what?
Feet.
Feet. What do I need to get to?
Miles.
Miles. What's the conversion for feet to miles?
That's a good question.
That's a good question. Who does know that?
Mile equals... Siri knows this.
5,280 feet. Yes, you could ask your Siri. So, what do I have to do? What's the process to get this into miles?
125 divided
125 divided by 5280.
by, let me have that one.
Oh, let's just reduce it down to a fraction here. We'll stay exact. Oh, that's obnoxious too. Let's just leave it as it is. 125 over 5280. Yeah. Because I crossed off the feet. Okay, radius is done. Theta, how do I get theta?
You just multiply by 2 pi.
By 2 pi. So it's 2 pi radians. Time is 20 seconds. See how labels are important here? What do I want to get to? I want to get to hours. Let's do a couple of conversions. So what's a conversion you know that we can use? Seconds and minutes? What do you know about seconds and minutes? There are 60 seconds in 1 minute. And you guys know how to put these in the right spots here? I'll teach that. You guys know that? Okay, that's going to get me into minutes. Now what?
60 minutes on the bottom.
60 minutes in 1 hour. So we're going to have 20 over 3600, 2 over 360, 1 over 180. Am I right?
Yes.
1/180th of an hour. And our whole goal was to find big V. Yep, we already did theta. Theta was the easy one. All right, so the radius is 125 over 5280. Multiply that by 2 pi over 1. That's all going to get divided by 1 over 180. Yep, now I chill. Because it's all calculator work from here. You get to try.
Why are you doing 2 pi over 1? Wouldn't it be 2 pi?
It is. That 2 pi divided by 1 is still 2 pi, just so I can see what gets multiplied here. Anytime it's next to a fraction, I like to keep everything fractions.
Alright.
Just the way I roll. Yes, I would do that too, and then pick up a calculator and see how you do on your own with the calculator. I know I can type this in. Can you type it in?
I don't know the short. You know this one, Kenley?
Yeah.
How fast is that Ferris wheel traveling?
Should we keep it in terms of pi?
Nope, let's, because we want to know. If I leave pi in there, I don't know how fast it is, so multiply the pi in. See what I get.
Pretty big. Decimal. Decimal. I got.
Yeah.
Yeah, me too.
So you got about 27 if we go to the nearest mile per hour?
Yeah.
Oh, well, go ahead and try it, see if you can get it.
Wait, Alexa's in then.
I'm waiting.
I mean,
27 miles an hour on the Ferris wheel.
that's
really
pretty fast.
That's pretty fast.
For a Ferris wheel?
Seems like it, doesn't it?
I feel like the children would need to be strapped.
A Ferris wheel go like, and that one going like talk about a relaxing ride.
Cars would be flying off.
That's not romantic.
You know how there's like those really fast Ferris wheels?
The really sketchy one?
Yeah.
Okay, our last one.
You sit and you have to go like this. Yeah, I thought I was gonna.
Okay, we've got a belt connecting 2 pulleys together.
You.
Yeah,
One pull is hard enough.
I know.
Quit.
Okay, a belt connecting 2 pulleys.
Looks like a safety pin.
It does look like a safety pin. 7 centimeters. 3 centimeters.
This is already looking really complicated.
This one is making 40 RPMs. What does that stand for, RPM?
Revolutions per minute.
Revolutions per minute or rotations per minute. 40 RPMs. I would like to find the angular velocity of the small one. I want to find two things. I want to find angular velocity here and RPM. We haven't done that yet. Okay. Now we had the kind where the two gears were stuck together, and I said there was a trick to doing that one. What was the trick if they were stuck together? What did you have to remember?
The S is the same.
The S is the same. If this thing is a belt moving these two pulleys, or whatever you want, gears, what's going to be, it would have to be the same there,
No. Yeah.
besides S.
Let me the belt.
Theta.
No.
RPM.
No. This one's going to spin a lot more times than this one will spin. The velocity. The whole thing's got to be traveling at the same speed. So the linear velocity has to be the same. So the trick here, big V's are equal. V1 has to equal V2. So it's going to be our goal to find the velocity of the larger one. Then we can come over here and find what we want to afterwards here. So let's see what's given on the big one. What is the 7 centimeters giving me?
Radius.
Radius is 7 centimeters. 40 rotations per minute is giving me two pieces of information. What two pieces is this giving me?
Time.
Time and almost theta. This is almost theta and time. Both of them. So how do I get theta? Times by 2 pi. You guys are getting good there. 80 pi. Radians. Time? 1 moment. So that's everything you need to find the linear velocity here. The formula is R times theta divide by time.
We don't need to divide by time.
We don't really need to divide by time. 7 times 8 is 560 pi. What would the units be there?
Would it be
Centimeters per minute.
Yep, it's a distance and time. So if you look, once you've got this listed out with your labels, definitely put labels down. It's centimeters in minutes. So centimeters per minute. Okay, let's see what am I looking for on the small pulley?
the RPM.
W first. Let's just do one at a time. I'm looking for W. What else do I know about this small pulley?
Radius.
The radius is 3. What else do I know about that small pulley?
The velocity.
I know the big V is 560 centimeters per minute. I'm looking for W. V equals RW. New formula. So it's 3 times 560.
We give it a 5 then?
Oh, I put that in the wrong spot. Oh, I don't know. Didn't write it down. 560 pi. And then I screwed it up anyway, so it's a good thing I was ahead of you. So big V is 560 pi. Radius is 3. W is what I'm looking for. What are we getting there?
Not a pretty number.
Not a pretty number?
586.
Let's just leave it like that then. 560 pi over 3. What would that be?
Not a pretty.
Units?
Oh, units. Would
Yeah.
it be revolutions per minute?
RPMs, revolution. No, it would be radians per minute. Okay. That's how many radians per minute. That's angular velocity is always radians per time. Now I asked for RPMs, revolutions per time. Well, if it's traveling through 560 pi over 3 radians, how do I turn that back into revolutions? You've been going revolutions to radians all the time. How do you get from revolutions to radians? Multiply by 2 pi. If I go backwards, what am I going to do? Divide by 2 pi. Every 2 pi is a revolution. So if I want to turn this into revolutions per minute, I'm just going to take this answer and divide it by 2 pi.
You screwed it up a little bit.
Yep. So we're going backwards. We're going back to almost theta. And then it's just work your fractions correctly.
We can get rid of the pi.
So it's 560 pi over 3 multiplied by 1 over 2 pi. Pi's will cancel. 2 will reduce to 560. 280. So 280 over 3 RPMs. Okay, I've got a little worksheet for you today.
Oh.
Oh.